Question 1. Find the limit as x approaches 3 of the quantity x² minus 9 all over x minus 3.
A, 6. B, 0. C, 3. D, the limit does not exist.
The answer is A, 6. Factor the numerator as x minus 3 times x plus 3. Cancel the x minus 3 to get x plus 3. Substitute 3 to get 6.
20 questions to test whether you could pass the calculus CLEP exam and save hundreds of dollars by skipping the full college course. Think you've got what it takes? Get 16 right and you're likely ready for the full exam.
Question 2. Find the limit as x approaches 0 of sine of 3x divided by x.
A1, B, 3, C, 0, D, 1/3.
The answer is B, 3.
Rewrite the expression as 3 times sine of 3x over 3x. Since sine of u over u approaches 1, the limit equals 3.
Question 3. Find the value of a that makes the piecewise function f of x continuous at x equals 2, where f equals x² for x less than 2 and a times x plus 1 for x at least 2.
A1, B, 1/2, C, 3/2, D, 2.
The answer is C, 3/2.
Set the two pieces equal at x equals 2. 2 squared is 4, and a times 2 plus 1 is 2a plus 1. So 4 equals 2a plus 1, giving a equals 3/2.
Question 4. Find the limit as x approaches 0 of 1 minus cosine x all over x².
0, B, 1,
C, 2.
D, 1/2. The answer is D, 1/2.
Multiply top and bottom by 1 plus cosine x. The numerator becomes sin²x. Sin²x over x² approaches 1, and 1 over 1 plus cosine x approaches 1/2. So the limit is 1/2.
Question 5. Find the limit as x approaches 0 of the square root of x plus 1 minus 1 all over x.
A1/2, B1,
C, 0.
D, 2.
The answer is A, 1/2.
Multiply top and bottom by the conjugate, square root of x plus 1 plus 1. The numerator becomes x, which cancels, leaving 1 over square root of x plus 1 plus 1. At 0, that is 1 over 2, or 1/2. Question 6. Find the derivative of f of x equals the quantity 2x plus 1 raised to the 5th power. 5 times the quantity 2x plus 1 to the 4th.
B, 10 times the quantity 2x plus 1 to the 4th.
C, 2 times the quantity 2x plus 1 to the 4th. D,
10 times the quantity 2x plus 1 to the 5th.
The answer is B, 10 times the quantity 2x plus 1 to the 4th. By the chain rule, bring down the 5 to get 5 times the quantity to the 4th. Then multiply by the derivative of the inside, which is 2. That gives 10 times the quantity 2x plus 1 to the 4th.
Question 7. Find the slope of the tangent line to the curve y equals x² at x equals 3.
A,
3. B. 9. C. 2. D. 6.
The answer is D. 6.
The derivative of x squared is 2x. Evaluating at x equals 3 gives 2 times 3, which is 6.
Question 8. Find the derivative of f of x equals x cubed times the natural log of x. A 3x squared times natural log of x. B. 3x squared plus x squared. C. 3x squared times natural log of x plus x squared. D. X squared times natural log of x plus 3x squared. The answer is C. 3x squared times natural log of x plus x squared.
Using the product rule, the derivative is 3x squared times natural log of x plus x cubed times 1 over x. The second term simplifies to x squared, giving 3x squared natural log x plus x squared.
Question 9. Find the derivative of f of x equals e to the 2x times sin x. A to the 2x times the quantity 2 sin x plus cosine x. B. 2e to the 2x times cosine x. C to the 2x times the quantity sin x plus cosine x. D. E to the 2x times the quantity 2 cosine x minus sin x. The answer is A. E to the 2x times the quantity 2 sin x plus cosine x. By the product rule, the derivative of e to the 2x is 2e to the 2x times sin x plus e to the 2x times cosine x. Factoring gives e to the 2x times the quantity 2 sin x plus cosine x.
Question 10. A ladder leans against a wall so that x squared plus y squared equals 25. When x is 3 and y is 4, the base slides away from the wall at a rate of 2 feet per second. Find the rate of change of y.
And negative 3/2 feet per second. B. 3/2 feet per second. C. Negative 8/3 feet per second. D. Negative 2 feet per second. The answer is A. Negative 3/2 feet per second. Differentiate both sides with respect to time to get 2x times dx dt plus 2y times dy dt equals 0. Solve for dy dt to get negative x over y times dx dt, which is negative 3/4 times 2, equal to negative 3/2 feet per second.
Question 11. Find all x values where the function f of x equals x cubed minus 3x has a horizontal tangent line.
A. X equals 0 only. B. X equals plus or minus 1. C. X equals plus or minus square root of 3. D. X equals 3. The answer is B. X equals plus or minus 1. Set the derivative 3x squared minus 3 equal to 0. That gives x squared equals 1, so x equals plus or minus 1. Question 12. Find the derivative of f of x equals tangent x and evaluate it at pi over 4.
A secant squared x, and the value is 1.
B. Secant x tangent x, and the value is square root of 2. C.
secant²x, and the value is 2.
D. Negative cosecant²x, and the value is negative 2.
The answer is C, secant²x, and the value is 2.
The derivative of tangent x is secant²x. At pi over 4, secant equals square root of 2, so secant² equals 2.
Question 13. Evaluate the definite integral from 0 to 2 of 3x² dx.
A6, B12, C4,
D8. The answer is D, 8. The antiderivative of 3x² is x³. Evaluating from 0 to 2 gives 8 minus 0, which is 8. Question 14. Find the indefinite integral of e to the 3x dx. A 1/3 e to the 3x plus c. B. 3e to the 3x plus c. Ce to the 3x plus c. D. 1/3 e to the x plus c. The answer is A. 1/3 e to the 3x plus c.
Integrating e to the 3x gives e to the 3x divided by 3 plus the constant c, because we divide by the coefficient of x inside, which is 3.
Question 15. Evaluate the definite integral from 1 to 4 of the quantity 2x plus 3 dx.
18,
B. 24. C. 21. D. 30. The answer is B. 24. The antiderivative is x² plus 3x. At 4, it is 16 plus 12, which is 28. At 1, it is 1 plus 3, which is 4. The difference is 24. Question 16. Find the derivative with respect to x of the integral from 0 to x of sine of t² dt.
A. Cosine of x². B. 2x times cosine of x².
C. Sine of x².
D. Sine of x² times 2x.
The answer is C, sine of x². By the fundamental theorem of calculus, the derivative of the integral from 0 to x of f of t equals f of x. Here, that is sine of x². Question 17. Find the indefinite integral of x times e to the x dx. A. E to the x plus c. B. 1/2 x² e to the x plus c. C to the x times the quantity x plus 1 plus c. D to the e times the x times the quantity x minus 1 plus c. The answer is D, e to the x times the quantity x minus 1 plus c.
Use integration by parts with u equals x and dv equals e to the x dx. This gives x e to the x minus the integral of e to the x, which is x e to the x minus e to the x, or e to the x times the quantity x minus 1, plus c.
Question 18. A particle moves with position s of t equals t cubed minus 6t² plus 9t. At what times is the particle at rest? That is, velocity equals 0. At t equals 0 and t equals 3. B. T equals 2 only. C. T equals 3 and t equals 9. D. T t equals 1 and t equals 3? The answer is D. T equals 1 and t equals 3. Velocity is the derivative, 3t squared minus 12t plus 9, which factors as 3 times t minus 1 times t minus 3. Setting this to 0 gives t equals 1 and t equals 3. Question 19. A rectangle has a perimeter of 20. What dimensions give the maximum area? A 4 by 6. B 5. 2 by 8. D 3 by 7. The answer is B, 5 by 5. If length plus width is 10, then area equals length times 10 minus length. The derivative, 10 minus 2 times length equals 0, gives length 5. So the rectangle is 5 by 5, a square. Question 20. A particle has velocity v of t equals 2t minus 4. Find the total distance traveled over the interval from 0 to 3.
A negative 3. B 3. C 5. D 9.
The answer is C, 5. Total distance is the integral of the absolute value of velocity. Velocity is negative from 0 to 2 and positive from 2 to 3. The integral over the first part gives 4, and over the second part gives 1, for a total of 5.
So how did you do?
11 or fewer, and there are real gaps to close. 12 to 15, you're on track. 16 or more, you're likely ready.